All right, so today we're going to look at some exponential growth and exponential decay models. So take a second here and write these equations down, because we talked about one in class yesterday, but I want to make sure you have both of them down. And really the only difference between the two of them is the fact that one has a plus sign and one has a minus sign. All right, so that growth model has the plus sign, and our decay model actually has a minus sign. I'm sorry, this should be a minus right there. All right, so a minus right there. And both these mean kind of the same thing. So I want to go through see what the A, what the R, what the T is. This is a reminder of yesterday. So the A is always your amount that you are starting with. Amount you start with. A lot of times this is looked at as like the money or the bacteria, all sorts of different things this could be. The rate is R, so this is a rate, and this is as a decimal. And T is always time. Now, usually time is measured in years. However, time can also be broken down into smaller increments. It all depends on what amount of time you're talking about. All right, so decay, those are exactly the same things. If you want to take a second to label those, that would be great. All right, so all we're going to do today is just going to look through a couple of problems. So our first one we're looking at is a growth problem. So pretty typical problem involving money and interest rates, and it's if it's compounded every year, not every 6 months or months, something like that. So it's kind of a weird way to do it. Most CDs do more often than that. So when you're investing in something like this, make sure that you talk to your investment person about how often it is compounded. So after your grandparents pass away, they leave you with $3,000. Very nice of them. They didn't have to do that, but good for them. Decide to invest the money in a certificate of deposit, or what's called a CD. It earns 2.1% interest. How much would this CD be worth after 3 years? So what we've got here is we've got to look at inside of our problem, what are our key factors? So the key numbers we have, so the first one obviously is the $3,000. That's how much you got, as well as our interest rate, so 2.1%, and 3 years is the other key thing. So it's a growth, so your money hopefully will grow when you have a CD. So we're going to use that first equation, y equals A times 1 plus R to the T. And all we're going to do is we're going to plug these numbers in. So A is our starting, so that's the $3,000. 1 plus R, remember R is as a decimal, so 0.021. And T is the time, so 3 years. So next thing you do, you just have to do your multiplication, division, exponent, stuff like that. So first thing I would do is add up your rate. So keep this as y equals 3,000 and then 1.021 to the third. And then next I would do your exponent, so 1.021 to the third power. You get y equals 3,000 times 1.0643, and then you just have to multiply that by 3,000. So in that amount of time, that's 3 years, you should end up with earnings. So you have $3,192 and 99.6. So round it up to 3.00. So in that 3 years, you earned $193, which is pretty cool. So it's quite a bit of money with a pretty small interest rate. Okay, so that is a growth one. So let's look at a decay one. What I want you to do is pause the video for a second and try this on your own and see what happens. What I really want you to look at is the time is not going to be in years this time. So the increment is 3 minutes, and it's wondering what happens after 18 minutes. And I get circled over here. So think, how can you adjust what T is going to be based on that? So take a couple minutes, try it on your own. All right, you should have that done by now, so you can get to it. So looking at what else we've got. So we have our same formula, so y equals a1 minus r to the t power. Because we're doing the minus because it's a decay, you should be having your infection going down. So our starting value, A, is this 2.3 million, or 2,300,000 equals 1 minus, and our rate is 3.1%, so 0.031, and this is the t part is what happens. So they're counting increments of time as 3 minutes. So what's going to happen is you're actually going to go through 6 increments of time. So that t is going to be 6. So I just have to go through and do this. So plug it out. So y equals, this is going to be 0.97 to the 6. So figuring that 0.97 to the 6th power out. And that ends up being, so times 0.83297. So I'm going to multiply that by my 2.3 million. And you get 1,915,835.6. Really can't have a 0.6 of a bacteria, so I'll say that's 6 there. So you've decreased yours by 1 million, and it'll keep going down and down from there. All right, so that's exponential decay and exponential growth. That should be enough for you to get some of those word problems don't even stuck on. So have a great night.